In this video, we're going to break down relays, what they are, how they work, and how to wire them properly. If you're new to low voltage or alarm systems and feel confused about NO, NC, COM, or coil terminals, don't worry. By the end of this video, it'll all make sense. Let's start with the basics. A relay is simply an electrically controlled switch. It allows a small control signal, like a PGM output from an alarm panel, to safely switch a larger voltage or current. In other words, the relay isolates the control side from the load side. There are two main parts of a relay: the coil and the contacts. The coil is the control side. When voltage is applied to the coil, it creates a magnetic field that moves an internal switch. The contacts are the switching side. These are usually labeled COM, NO, and NC. COM stands for common. NO stands for normally open, which means the circuit is open when the coil is not energized. NC stands for normally closed, which means the circuit is closed when the coil is not energized. When the coil is powered, the internal switch changes position. The COM moves from NC to NO. That's all a relay is, a switch that moves when electricity energizes a coil. You can use relays if you need to use a high-powered siren where the power requirements of the siren is higher than what the alarm panel can handle. In this case, you wire the siren to its own power source and pass one of its power outputs through the relay contacts, the common and normally open. There are different types of relays. A basic relay will energize when the control signal is applied to it and de-energize when the signal is removed. This Songlay brand relay is an example of that. Relays can also be powered by different voltages depending on their specifications. This Songle board has a 3.3 volt relay. As I don't have a power source that can handle it, I will use a 5 volts relay board instead. This 5 volt board has two relays, and so it has two trigger inputs in 1 and in 2, so that the two relays are triggered separately.
This is the common, normally closed, normally open. So I'm wired into these two. The circuit is open. I'm not going to use this relay, I'm just going to use this one. This is my in wire. So these are my controls: ground, in 1, that controls this, in 2, that controls this. I'm not wired into it, I'm wired into in 1. And the VCC, this is what powers the coil. So there's an LED here for in 1, there's an LED here for in 2. These are my VCC and ground. If I connect to VCC, nothing happens. This is negative triggered, so if I plug into here, the relay is triggered, and notice up there the circuit is closed. We have a short circuit. If I remove, open circuit, short circuit, open circuit. And now I'm connected to common and normally open, normally closed, sorry. So now it's short circuit. When I when I trigger the relay, notice what's going to happen here. So it's short circuit, and notice the LED is on. It means the relay is triggered. So it works the opposite way.
Another type of relay is a latching relay. It needs a signal to energize just like a basic relay, but once the signal is removed, the relay maintains the energized status. To de-energize it, you need to send another signal. This Labco LR1 specialty relay is an example of that. Such a relay has special applications, such as fire, for example. Also, some relays allow for a positive and negative trigger or trip. The signal input will be labeled T plus and/or T minus instead of the usual IN input. This Labco relay happens to have this feature. Whether to use T plus or T minus depends on the panel that you are using to control the relay. In a following video, I will show you how to figure that out. When using the T plus to trigger the relay, you would connect the T plus to the positive power of the power source. To use T minus, you would connect T minus to the ground or negative of your power source. Thank you for watching. If you liked the video, please hit like and subscribe to help the channel. See you in the next one.